So I wanted to do a video on how to balance chemical equations, and that and also part of stoichiometry. So in order to balance chemical equations, you first should list all of the elements on the far left side under the equation. You can group polyatomic ions as one thing. I'll show you an example. Create a column for each chemical compound or term in the chemical equation. Then write the number of atoms of each element in that appropriate column. Balance the number of atoms of each element on the left and right of the arrow by multiplying. You can only multiply. If you multiply one element, you have to multiply the whole column by the same number. Those are the rules. Then once you do that, I like to double check that I'm balanced. And then you write the number at the top into the equation. And there you'll have the balanced chemical equation. Here is an example. All right, so it's hydrogen, H2, plus O2 yields water, H2O. And so the first step that we have is to write the elements that are involved in this chemical equation over on the left side underneath the equation. So we have hydrogen here, and we have oxygen here. And then the second step is to record the number of atoms of each element under each term. So I have two hydrogens, and I'm going to just write it really little, 0 oxygens, right? No oxygens in this H2, only two hydrogens. In O2, I have 0 hydrogens, and I have two oxygens. Usually when I do this, instead of 0, I'll just leave it blank. And then in H2O, I have two hydrogens and one oxygen. All right. So that's step 2. Now what do I have to do? I have to balance and make sure I have, because of the law of conservation of matter, I have to have the same number of hydrogens on the left of the arrow as I do on the right side of the arrow. So I'll start with the hydrogen row. This whole row is hydrogens. This whole row is hydrogens, right? So I have two hydrogens on the left and I have two hydrogens on the right. That's excellent. So check. The oxygen row, I have two oxygens on the left. I would add all this stuff here. 0 plus 2 is 2. On the right, however, I only have one oxygen, so that's not good. So I am going to multiply the 1 times 2 to get 2, right? So now I have two oxygens on the right and two oxygens on the left, but the rule says if I multiply one thing, I have to multiply everything in the column by the same number. Okay, so I multiplied the hydrogen by 2 because if I multiply the oxygen by 2 in this column, I have to multiply the hydrogen by 2. Okay, now if I go back and look, my hydrogens aren't matched up anymore, right? I have two hydrogens on the left, four on the right, so I have to multiply this one by 2. And now I'm good to go. So let me just double check myself. I have 4 hydrogens and 4 hydrogens, 2 oxygens and 2 oxygens. So now everything is balanced. My last step is to take whatever I multiplied that term by and put it up in front of that chemical. So I multiply the hydrogens by 2. So I'm going to do 2 there. The oxygen column, no multiplication at all, so I can leave it blank. Technically, that means there's a 1 here, but I don't write the 1. And finally, the water molecule, I multiplied this column by 2, so I'm going to put that right here. So my balanced chemical equation finally is, I'm going to just write it, so there's not a lot of writing. It's 2 hydrogens, 2 waters. That's how you would see a balanced chemical equation for this. You could tell there's 2 times 2, 4 hydrogen atoms plus 2 oxygen atoms. And on this side, we have 2 times 2 is 4 hydrogen atoms and 2 times 1, because this whole unit is multiplied by 2, 2 oxygen atoms, so I'm good to go. All right, so that's basically how you balance a chemical equation. Oops, let me undo this. We don't want this on here. Okay, so let's try this one. What are my steps again? My steps are 1, to write the elements on the left. Okay, so I have nitrogen and I have hydrogen. Okay, 2 is count each element. So I'm going to go ahead, I'm going to make my columns here. So I'm going to put the number of each element in each column. And I have to put it in the proper row. Okay, so I have 2 nitrogen atoms, 0 hydrogen in N2. I have 2 hydrogen atoms, 0 nitrogens in this one. And the last one here, I have 1 nitrogen and 3 hydrogens. Step 3 is to multiply to balance. Okay, so the first row, I have 2 nitrogens on the left side of the arrow. Here's the arrow. But I only have 1 nitrogen on the right side. So I'm going to multiply this. 1 times 2 equals 2. So now I have 2 and 2 for the nitrogens. But if I multiply one thing, I have to multiply everything in that column, up and down column, by the same number. So I had to multiply the next number by 2 also. So 3 times 2 equals 6. Okay? So now 2 nitrogens and 2 nitrogens. I'm all good. What about my hydrogen column? Well, on the left side of the arrow, I have 2 hydrogens, but on the right, I now have 6. So I'm going to use a different color. Multiply 2 times what is going to make 6? 2 times 3 equals 6. I would multiply everything in this column by 3, but there's nothing else in the column, so I don't have to worry about it. So let's double check our answers now. I have 2 nitrogens on the left, 2 nitrogens on the right. Check. Hydrogens, I have 6 on the left. That's right here. This whole thing is 6. And 6 on the right. Check. So my last step is to transfer the numbers up. I'll use black again. So here I don't transfer anything really. I could leave it blank or put in a 1 because that's 1 because I did not multiply anything under the nitrogen column. Under the hydrogen column, I multiplied this one by 3. If you could see that number with all that gobbledygook. So I'll put the 3 up here. This 3 goes right up there. And my last column here, I have multiplied that column by 2. So I'm going to put that number 2 right up there. So my balanced equation is N2, I'll just write it, plus 3H2 gives you 2NH3. That would be my balanced equation. Okay, let's try one more. Clear this. And do that. Okay, I wanted to try this one because if you notice here, SO4 is a polyatomic ion. And here's the important thing. SO4 only appears as a group in this whole equation. So in the whole equation, SO4 only appears as a group. You don't have like random S's or random oxygens in any of the chemicals that are being reacted here. It's always as a group of SO4. So because of that, I'm going to treat it as one thing. That's the polyatomic ion that I'm treating as one thing. So when step 1, write my elements over here on the left. I'll go aluminum, bromine. I'm just going across from left to right. Potassium is K. And then I'm going to use SO4 rather than as an element. I'm going to use it as like one thing because that'll just make my life easier. If you feel better about listing each element by itself, whoops, what happened there? If you feel better listing each element by itself, you're welcome to do that. It just makes it a little bit, I don't know what's going on here, more work to do. So I'm, dang it, making my rows and my columns. Okay. And now I'm going to go ahead and put in my counts. So I have 1 aluminum in this thing, and I have 3 bromines. And then my next thing, I have 2 Ks, potassium, and 1 SO4, 1 SO4 unit. And then the next one, I have 1 potassium K, and I have 1 bromine. And the last one, I have 2 aluminums. And see, this little 3 here means I have 3 of the SO4s. Everything in the parentheses multiplied by 3. So I have 3 SO4s. Okay, so now I'm going to balance this. Let me use a different color for my multiplications. Aluminum, on the left, I have 1. On the right, I have 2. So I'm going to multiply this 1 by times 2 to get 2. I have to multiply everything in the column by the same number. So 3 times 2 equals 6. You notice I have 2's both here and here, both places in the column. I have to multiply by 2. All right, good enough. So 2 on the left for aluminum, 2 in the right for aluminum. Good. I have bromine next. I have 6 on the left side now, but on the right I have only 1. So I'm going to multiply 1 times 6 equals 6. And everything in the column has to be multiplied by 6. So 1 times 6 equals 6. Okay, so next row, 6 and 6. Good to go. Check. Potassium, K. On the left, I have 2. On the right, I now have 6. That's not going to work. I have to multiply 2 times 3 equals 6. Everything in the column multiplied by 3, or by the number, which in this case is 3. 1 times 3 is 3. Okay, so checking potassium, 6 on the left, 6 on the right. And then finally my SO4, my sulfate, I have 3. This is a 3 here on the left and 3 on the right. Excellent, that checks. So now I think I'm totally balanced. Let me just double check myself to make sure. 2 and 2. For aluminum, bromine is 6, and I ended up with 6. Potassium is 6 and 6, and sulfate is 3 and 3. Good enough. Last step, I'm going to transfer the numbers. So the first one I got, I multiplied that by 2. So I'm going to transfer the number up here as a 2. The second term, I had to multiply this thing by 3. So I'm going to transfer that 3 up here to be a 3. The next one, I have it as multiplied by 6. So I'm going to transfer it. 6. The last one, I didn't multiply at all. So I'll either leave it blank or you guys know that that means it's actually a 1. Okay. So this is the balanced equation. Again, the steps are 1, write the elements. On the left. That's this thing here. Number 2 is count. count the elements in each column and row. Well, column in the rows, right? 3 multiply to balance. And then check and finally transfer. Okay. So pretty straightforward. Sometimes it can get a little bit complicated just because of the equations are tough, but the process is always the same.